Differentiate 1 over x cubed with respect to x from the first principle. And so the basis of the first principle is if there is a change in the x variable, then there will be a change in the y variable. And so I have y equals to 1 over x cubed. Remember, we're solving this with respect to x and from the first principle. So y plus change in y is equals to 1 over the change in x, x plus the change in x raised to power 3. And so this is y plus change in y equals to, we want to expand this now. This is 1 divided by, want to expand this. So to expand this binomial expression, I want to remind you of the Pascal triangle. So these are the coefficients when you have a degree of 1. And so 2, 1, 1, 3, 3, 1. This represents the coefficients of the terms when you have a power of 3. So this is the first, the second, and the third. So these are the coefficients. And so this would be, in brackets, I have a coefficient of 1. And that's 1x raised to power 3. Change in x raised to power 0. Plus the coefficient that is 3. X raised to power 2. And change in x raised to power 1. Plus 3 x raised to power 1 and change in x raised to power 2, and finally that's 1x raised to power 0 and change in x raised to power 3. What I've just done here is to make use of the binomial expansion principle. So this is 1, all of this 1 divided by this. So y plus change in y is equals to 1 divided by 1 x cubed, that's x cubed. Change in x raised to power 0, that's 1. So I have this as 3x squared. Change in x plus 3x. Change in x all square plus x raised to power 0 is 1, and then I have change in x raised to power 3. And so this is the first equation we have, that's 1. This is the second one. And so we can subtract equation 1 from equation 2. So I have this as y plus change in y minus y equals to 1 divided by x cubed plus 3x squared, change in x, plus 3x, change in x all square, plus change in x all cube, minus what we have here is 1 over x cubed, so minus 1 over x cubed. So this now gives us change in y equals to, if we find the LCM of all that we have here, because remember we are subtracting this, and so when you find the LCM of all that you have, this would be, let's have this first, x cubed plus 3x squared, change in x, plus 3x, change in x all square, plus change in x raised to power 3, all of this in the brackets, and then you have x cubed. So that's the LCM of the denominator. All of this is seen as a single expression. That's the denominator for this, so it's seen as a single expression. So this all of these divided by these, you have x cubed left, and then I have minus all that we have here, all of this divided by x cubed. What would I have left will be x cubed plus 3x squared, changing x, plus 3x, changing x all squared, plus changing x raised to power 3. And so we can begin to open up the brackets. So I have a change in y equals to x cubed minus x cubed minus 3x squared changing x minus 3x changing x all square minus changing x raised to power 3, then divided by all that we have in the denominator, x cubed plus 3x squared changing x plus 3x changing x all square plus changing x all cube, and then I have x cubed. So now let's subtract what we have here. This is now x cubed minus x cubed, that's 0. So changing y equals to minus 3x squared, changing x, minus 3x, changing x all square, minus changing x raised to power 3, divided by, so I'm just writing this, divided by x cubed plus 3x squared changing x plus 3x changing x all square plus changing x raised to power 3. Hope you're still following. Then we have x cubed. Please click on the subscribe button if you have not subscribed to this channel. And so now that we've subtracted, what we need to do now is to divide by changing y, because we need an expression for changing y. Remember, we are differentiating this with respect to x. And so to do that, we're going to have this as changing y over changing x to be equals to all that we have here. Do I need to write this here now? All that we have divided by change in x. You're dividing all that you have this fraction by changing x. And so this now becomes minus 3x squared changing x minus 3x into changing x all squared minus this changing x raised by 3, and so divided by all that we have here will be x cubed plus 3x squared changing x plus 3x changing x squared plus changing x all cubed. Now change this division to multiplication, you have times 1 over changing x. So when you look at the numerator, we observe that change in x is common in the numerator. So this is going to be minus 3x squared minus 3x changing x minus changing x all squared divided by, I have x cubed plus 3x squared changing x plus 3x changing x all squared plus changing x raised to power 3. So closing this, and then I have x cubed times 1 over change in x. So when you look at this, change in x cancel out this change in x here. And so at this point, we introduce in our limit, which is change in x tends to be 0. So at this point, I'm going to have this to be 0, this also to be 0, this will be 0, I'm going to have 0 here, 0. So the change in y over change in x will be equals to minus 3x squared divided by, so I'm left with x cubed times x cubed, and that's x raised to power 6. And finally, x squared is out, x is out here, so I have minus 3 over x raised to power 4. And so the value here is minus 3 divided by x raised to power 4. So you can go over this again from the beginning and leave your comment in the comment section. Thank you for staying tuned.